Hello there, and welcome to Cosmic Slumber. Tonight we are sinking slowly into the deep, dark water where whales sing. Their songs can travel for hundreds of miles, carried through water far more efficiently than sound ever travels through air. Some songs last for over 20 minutes before repeating. Some change gradually every year, drifting across an entire ocean population like a slow, shared fashion. Some are so low in pitch that human ears can barely register them at all, felt more than heard, moving through the chest like a distant heartbeat. The closer we listen to these long, patient songs, the less they feel like simple animal noise, and the more they feel like something closer to music, composed and performed in a world almost entirely without light. If you enjoy these gentle journeys, I invite you to like, subscribe, or leave a thought below. It helps other sleepy minds find their way here, too, one quiet current at a time. But for now, all you need to do is relax. Let your shoulders soften. Let your eyes grow heavy. Let your thoughts sink slowly downward, past the sunlit surface, into the deep, dark blue where a whale is quietly, patiently singing. Let's begin. Only male humpback whales are known to sing the long, structured songs most people associate with whale sound. While many whale species produce a wide range of calls, the elaborate, musically structured songs that stretch on for many minutes are most closely associated with male humpback whales specifically, typically produced during breeding season in warm, tropical waters where these whales gather each year. A single humpback whale song can last anywhere from around 5 minutes to well over 20 minutes. Rather than a brief call or single note, a humpback song unfolds as a long, structured sequence, often repeating in a continuous loop for hours at a time, one extended musical passage flowing directly into the next without any real pause between individual repetitions. Whale songs are built from smaller repeating units, much like a piece of music built from phrases and verses. Researchers studying humpback song structure have identified individual sound units that combine into repeated phrases, which themselves combine into longer, larger themes, and those themes link together to form the complete song, a layered, hierarchical structure with genuine similarities to how human music is often organized. All the male humpback whales within a single population tend to sing nearly the same song during any given breeding season. Rather than each individual whale composing something entirely unique, males within the same general population sing remarkably similar versions of a shared song, suggesting the song functions almost like a communal composition passed between individuals, rather than a personal, individually invented performance. Humpback whale songs gradually change and evolve over the course of each breeding season. Small variations introduced by individual whales can spread gradually through the wider population, meaning the shared song is not a fixed, unchanging piece, but something that continues shifting subtly week by week, much like a slow, ongoing collaborative composition being quietly revised by an entire population at once. Whale songs can change so dramatically over several years that an older recording becomes almost unrecognizable compared to a more recent one. Researchers comparing recordings taken years apart have documented humpback songs evolving so significantly over time that the song sung by a population a decade earlier bears little resemblance to what the very same population sings today, evidence of an ongoing, generational cultural shift playing out entirely underwater. An entirely new song can sometimes spread rapidly across an ocean basin, replacing an older, more familiar one. In a phenomenon researchers have documented in the waters near Australia, an entirely new humpback song style, originating from a distant population, was observed spreading rapidly westward across multiple neighboring populations within just a few years, eventually replacing the previously established local song almost entirely. Scientists still do not fully understand exactly why humpback whales sing. While the timing and context, primarily during breeding season, strongly suggests some connection to mating and reproduction, researchers have proposed several competing explanations, including attracting females, communicating with other males, or establishing some form of social or spatial awareness, without any single explanation having been fully confirmed above all the others. Female humpback whales have rarely been directly observed responding obviously to male song. Despite the widespread assumption that singing functions primarily to attract a mate, direct observations of females actively approaching or clearly favoring singing males remain relatively limited, leaving open the possibility that song may serve additional or different purposes beyond simple mate attraction alone. Some researchers believe whale song may function partly as a way for males to communicate or negotiate with one another, rather than only with females. Because singing males are sometimes observed near other males, and because aggressive interactions between competing males do occur during breeding season, some scientists suspect song may play a role in male-to-male communication or spacing, alongside, or even instead of, its more commonly assumed role in courtship. Humpback whale song can travel remarkably long distances underwater, especially in the right ocean conditions. Sound moves considerably more efficiently through water than through air, and under favorable underwater conditions, whale song has been detected by hydrophones many tens of miles away from a singing whale, allowing communication across distances that would be entirely impossible using sound traveling through open air instead. Sound travels roughly 4 times faster through water than it does through air. Because water is denser and less compressible than air, sound waves move through it considerably more quickly and, in many conditions, more efficiently as well, a physical property that helps explain why whales, and many other marine animals, rely so heavily on sound rather than sight for long-distance underwater communication. Whales sing primarily, though not always exclusively, at night. Observations suggest that singing activity tends to increase during nighttime hours, though the reasons behind this particular timing pattern remain somewhat uncertain, with some researchers speculating it may relate to reduced competing background noise, feeding patterns during the day, or simply established behavioral rhythms passed down within the population. A singing humpback whale typically remains in roughly the same position in the water column while producing its song. Rather than actively swimming while singing, a male humpback often hangs relatively still in the water, sometimes positioned at a particular depth, for the extended duration of a full song performance, conserving energy while its voice carries outward through the surrounding water. Whale song can be detected and recorded using underwater microphones called hydrophones. Because whale vocalizations occur underwater, specialized underwater microphones are required to capture them clearly, allowing researchers to record, analyze, and compare whale songs across different locations, seasons, and years, forming the foundation of decades of accumulated scientific research into whale vocal behavior. The first widely publicized recordings of humpback whale song were released to the public in the early 1970s. A landmark recording released under the title Songs of the Humpback Whale introduced many people around the world to whale song for the very first time, contributing significantly to growing public interest in whale conservation during that particular era, and helping shift broader cultural attitudes toward whales more generally. Whale songs were included on the Voyager Golden Record, sent into space aboard NASA's Voyager spacecraft. Alongside music, greetings in many human languages, and various sounds representing life on Earth, humpback whale song was specifically selected for inclusion on this record, intended as a potential message to any future extraterrestrial intelligence that might one day encounter the spacecraft drifting through deep space. Blue whales produce some of the loudest sounds of any animal on Earth. Despite their calls often being too low in pitch for human ears to fully perceive a sound in the usual sense, blue whale vocalizations can reach volumes considerably louder than many familiar everyday sounds, traveling extraordinary distances through the ocean as a result of both their intensity and their very low frequency. Blue whale calls are often too low in pitch for human ears to hear without technological assistance. Many blue whale vocalizations occur at frequencies below the typical range of human hearing, meaning that although the sound waves are genuinely powerful, they must often be sped up or otherwise processed electronically before becoming clearly audible to human listeners in recordings. Blue whale calls have gradually become lower in pitch over the past several decades, according to long-term recordings. Researchers analyzing decades of accumulated blue whale recordings have documented a slow, gradual downward shift in the pitch of their calls over time, a subtle trend that remains an active area of ongoing scientific investigation, with several possible explanations still being carefully considered and studied. Fin whales produce extremely low, powerful pulsing calls that can also travel for very long distances underwater. Alongside blue whales, fin whales are known for producing some of the lowest frequency vocalizations found among marine mammals, contributing to a wider underwater soundscape of long distance, low-pitched communication occurring across entire ocean basins largely beyond human perception. Whale song and other whale vocalizations can be significantly disrupted by noise pollution from human shipping activity. Increasing underwater noise generated by large commercial ships has been documented interfering with the ability of whales to communicate effectively across long distances, potentially forcing some individuals to call louder, shift the pitch of their calls, or communicate less effectively overall as a direct result of this added background noise. Some researchers believe rising ocean noise levels may be gradually shrinking the effective range over which whales can successfully communicate. As background noise from increased shipping traffic continues to rise in many busy ocean regions, some studies suggest the overall distance across which whale calls can be clearly received and understood by other whales may be gradually decreasing, a subtle but potentially significant consequence of a noisier modern ocean. Whales are not the only marine animals that use sound extensively underwater, though their vocalizations are often the most widely recognized by humans. Many other marine species, including dolphins, certain fish, and even some invertebrates, rely on underwater sound for communication, navigation, or hunting, meaning the ocean is filled with a far richer and more layered soundscape than most people typically imagine. Sperm whales communicate using patterns of clicks rather than the long, continuous songs associated with humpback whales. Rather than producing melodic, song-like vocalizations, sperm whales use structured sequences of clicks, sometimes called codas, which appear to vary somewhat between different social groups, functioning as a distinct form of vocal communication entirely separate from the singing behavior observed in humpback whales. Sperm whale clicks are also used for echolocation, helping the whale navigate and hunt in complete darkness. Beyond potential social communication, sperm whales rely heavily on their powerful clicking sounds to locate prey deep in the ocean, where sunlight never reaches, using returning echoes to build a detailed acoustic picture of their surroundings, similar in basic principle to how bats navigate using sound in complete darkness above the surface. Sperm whales produce some of the loudest clicking sounds of any animal, generated specifically for the purpose of echolocation. The clicks produced by sperm whales while hunting rank among the most intense sounds generated by any living creature, allowing these deep-diving whales to detect prey such as squid at considerable distances within the pitch-black depths of the deep ocean, far below where any natural light can reach. Different whale species communicate using distinctly different types of sound, reflecting their varied lifestyles and environments. While humpbacks are known for their long, structured songs and sperm whales for their patterned clicks, other species, including orcas and various dolphin species, use their own distinct combinations of whistles, calls, and clicks, each adapted to their particular social structure and typical underwater environment. Orcas, also known as killer whales, use distinct vocal dialects that can differ noticeably between separate family groups, called pods. Different orca pods, even those living in relatively similar geographic areas, often display their own unique combinations of calls, functioning almost like distinct dialects, allowing researchers to sometimes identify which specific family group a particular orca likely belongs to based solely on its vocalizations. Young whales may learn important vocal patterns partly by listening to and imitating older members of their social group. Similar in some ways to how young songbirds learn their species' typical songs by listening to adults around them, some evidence suggests young whales may develop their own vocal patterns partly through a process of listening to and gradually imitating more experienced whales within their social environment. Whale song appears to travel further and clearer in deep ocean water compared to shallower coastal areas. Because deep water tends to contain fewer obstructions and different acoustic properties compared to shallower coastal regions, whale song and other long-distance calls generally propagate more effectively and travel considerably farther when produced in deeper, more open ocean environments. A layer of ocean water known as the deep sound channel can carry whale calls across extraordinarily long distances. At a certain depth, variations in water temperature and pressure create a natural channel that traps and efficiently carries sound waves for very long distances with minimal loss, a phenomenon some whale species may take advantage of, whether by instinct or coincidence, when producing their loudest, most far-reaching calls. Whales are believed to use sound not only for communication but also to help build a broader sense of their surroundings. Beyond simple direct communication with other whales, some researchers believe whales may use sound more broadly to gather general information about their environment, including the presence of other animals, underwater terrain features, or changing ocean conditions nearby. Baleen whales, the group that includes humpbacks and blue whales, produce sound differently compared to toothed whales like sperm whales and orcas. Because baleen whales lack the specialized structures toothed whales use for echolocation clicks, they generate their long, low-frequency calls and songs through an entirely different vocal mechanism, involving the movement of air within specialized internal structures rather than anything resembling a traditional exhale through the blowhole. Whales do not breathe air while singing, despite needing to periodically surface to take a breath. Because singing whales typically remain submerged for extended stretches while performing their long songs, they must rely on air already held within their respiratory system, recycling it internally to help produce sustained sound, rather than continuously exhaling air the entire time the song continues. A singing humpback whale can produce sound continuously for many minutes without needing to surface for air. Because whales can hold their breath for considerably longer than most air-breathing animals, a male humpback can typically complete a lengthy, uninterrupted song performance while remaining submerged the entire time, surfacing only briefly to breathe before continuing on with the next repetition of the very same song. Whale songs recorded in one part of the world's oceans can sound noticeably different from songs recorded in a completely separate ocean region. Because humpback populations in different major ocean basins tend to remain relatively separate from one another, their respective songs can develop along independent paths, resulting in noticeable distinct song styles and structures depending on which broad geographic population is being recorded. Researchers use long-term recordings of whale song to help track population movements and behavior over time. By comparing recordings gathered across different years and locations, scientists can identify patterns related to migration timing, population mixing between previously separate groups, and broader shifts in vocal behavior, turning whale song itself into a genuinely valuable, ongoing scientific research tool. Whale calls can sometimes be picked up by underwater listening networks originally built for entirely different purposes, such as monitoring for distant seismic activity. Specialized underwater microphone networks originally installed to detect nuclear tests or study ocean seismic activity have occasionally proven useful for incidentally recording and studying whale vocalizations traveling across enormous underwater distances, an unexpected secondary benefit of technology developed for an entirely different original purpose. Some whale populations appear to reduce their calling activity in the presence of loud, nearby ship noise. Rather than simply calling louder to compensate for increased background noise, some studies have observed certain whale populations reducing their overall vocal activity when exposed to particularly loud or persistent nearby noise, potentially reflecting an attempt to avoid drawing unwanted attention, or simply a disrupted communication pattern under especially challenging acoustic conditions. Whale song frequencies often fall within a range that overlaps significantly with certain types of human-generated ocean noise. Because many common sources of ocean noise pollution, including large ship engines, happen to produce sound within a frequency range that overlaps considerably with typical whale vocalizations, this overlap can make it especially difficult for whales to clearly communicate over long distances in increasingly busy, noisy shipping areas. Humpback whales are known to sing not only during breeding season, but occasionally, though less frequently, during other parts of the year as well. While the most elaborate, structured songs are strongly associated with the breeding season specifically, some evidence suggests humpbacks may produce simpler or less complete vocalizations at other points throughout the year, though the specific purpose behind this less common, off-season singing remains less well understood. Whale song has been studied for potential structural similarities to certain patterns found in human music and language. Some researchers have drawn comparisons between the repeating phrase structures found in humpback song and certain organizational patterns observed in human music or even language more broadly, though scientists remain appropriately cautious about overstating these comparisons, given the vast underlying differences between whale cognition and human cognition. Whales appear capable of learning and adapting their vocal behavior throughout their lives, rather than being limited to a single fixed set of calls established at birth. Unlike many animals whose vocal repertoire remains largely fixed from a relatively early age, whales, and humpbacks in particular, continue adjusting and updating elements of their song throughout their lives, reflecting an unusually flexible, ongoing capacity for vocal learning and adaptation. Whale song can occasionally be heard, faintly, by humans on the surface, even without any specialized listening equipment. Under particularly calm ocean conditions, and when a singing whale happens to be relatively close and shallow, its song can occasionally be faintly perceived by someone on a boat directly above, carried upward through the water and briefly into the air, a rare, quiet, genuinely moving experience for those fortunate enough to encounter it. Humpback whale mothers and their calves communicate using especially quiet, low-amplitude sounds, sometimes described informally as whispering. Because loud vocalizations could potentially attract the attention of predators such as orcas, some researchers have observed humpback mothers and their young calves using unusually quiet, close-range sounds to communicate with one another, a gentle, protective adaptation suited specifically to the particularly vulnerable early period of a calf's life. Whale calves may begin practicing their own vocalizations from a very early age, gradually developing the sounds they will use later in life. Much like human infants gradually developing speech through early babbling and imitation, young whales appear to progressively refine their vocal abilities over time, gradually moving toward the more complete, structured calls and songs typically associated with fully mature adult whales. Whale song has been the subject of scientific study for several decades, yet many aspects of it remain genuinely unresolved. Despite considerable scientific progress in serious research into whale vocal behavior first began, fundamental questions regarding the precise purpose, meaning, and even the full extent of information potentially encoded within whale song remain active, ongoing areas of scientific investigation and debate. Humpback whales migrate across enormous distances each year, often singing primarily once they reach their warmer breeding grounds. After spending much of the year feeding in colder, nutrient-rich waters, humpbacks typically travel thousands of miles to reach warmer tropical or subtropical breeding areas, where the majority of elaborate song activity associated with breeding season tends to concentrate for a period of several months. Some humpback whale populations migrate close to 5,000 miles between their feeding and breeding grounds each year. This remarkable annual journey ranks among the longest migrations undertaken by any mammal on Earth, carrying humpbacks between distant, environmentally very different regions of ocean each year, driven by the seasonal availability of food in one location and suitable breeding conditions in another. Whales generally do not feed significantly while in their warm water breeding grounds, relying instead on stored energy reserves. Because many typical prey species are considerably less abundant in the warmer waters where humpbacks breed, whales largely rely on fat reserves built up earlier during their time spent feeding in colder waters, fasting for much of their stay in the breeding grounds while focusing energy instead on singing, mating, and caring for young calves. A male humpback whale may sing for many consecutive hours without any significant break. Because singing appears to require considerable sustained effort and energy, particularly given the fasting occurring simultaneously during the breeding season, a male's willingness to continue singing for such extended, largely uninterrupted stretches suggests the underlying behavior carries genuine, meaningful importance within the broader context of their reproductive strategy. Researchers sometimes use underwater recording devices attached temporarily to individual whales to gather especially detailed vocal and behavioral data. Non-invasive suction cup tags equipped with microphones and movement sensors allow scientists to gather detailed data directly from an individual whale's perspective, including precise information about depth, movement, and vocal activity, offering considerably more detailed insight than external recordings alone could typically provide. Whale song research has contributed meaningfully to broader conservation efforts aimed at protecting whale populations. By helping researchers better understand population structure, migration patterns, and the specific impact of ocean noise pollution, ongoing whale song research has directly informed conservation policy discussions and marine protected area planning in various regions around the world. Some governments and conservation organizations have implemented shipping speed restrictions specifically intended to reduce underwater noise and protect whale populations. In certain sensitive coastal regions, regulations limiting vessel speed have been introduced partly in response to concerns about underwater noise pollution and its documented impact on whale communication, alongside separate, related concerns regarding the physical risk of ship strikes. Whale populations in some regions have shown signs of recovery in recent decades, following earlier periods of severe historical decline due to commercial whaling. Following international restrictions on commercial whaling introduced in the latter half of the 20th century, certain whale populations, including some humpback populations, have shown encouraging signs of gradual recovery, offering cautious optimism alongside continued conservation efforts still very much ongoing today. Individual humpback whales can sometimes be identified by researchers based on the unique, distinctive pattern found on the underside of their tail fluke. Much like a human fingerprint, the specific pattern of markings on a humpback whale's tail is generally unique to that individual, allowing researchers to track and identify specific whales across multiple years and even across vastly different ocean regions using photographs alone. Photo identification of individual whales has helped researchers trace remarkable long-distance journeys undertaken by specific tracked individuals. By comparing photographed tail fluke patterns collected in different locations over time, researchers have documented individual whales traveling astonishing distances between separate ocean regions, occasionally connecting sightings recorded years apart and thousands of miles away from one another. Whale song is sometimes described by researchers using musical terminology, including references to themes, phrases, and even rhyme-like repeating patterns. While researchers are careful not to overstate direct equivalence with human music, the structured, repeating, hierarchical nature of humpback whale song has led many scientists to naturally borrow musical vocabulary when describing and analyzing its underlying structure and organization. Some evidence suggests male humpback whales occasionally sing together in loosely coordinated groups, sometimes called singing assemblages. Rather than always singing entirely alone, some observations suggest multiple singing males may occasionally be found relatively close to one another, raising interesting questions among researchers about whether some limited degree of loose vocal coordination or interaction might be occurring between them. Whale song can occasionally be heard by scientists monitoring underwater listening stations located extremely far from where the whale was actually singing. Thanks to the remarkable distances sound can travel underwater under the right conditions, whale songs have occasionally been detected by hydrophone networks located hundreds of miles from any known nearby whale population, offering valuable insight into just how far these long, patient songs can genuinely reach. Researchers have used artificial intelligence and machine learning tools in recent years to help analyze extremely large collections of recorded whale song. Given the sheer volume of accumulated whale song recordings gathered across decades of ongoing research, modern computational tools are increasingly used to help identify patterns, track subtle year-to-year changes, and manage datasets far too large for researchers to feasibly analyze manually using traditional methods alone. Whale song remains a rare example of a non-human vocal tradition that appears to genuinely change and evolve over time, much like a living cultural tradition. Because humpback song content shifts gradually across seasons and years, sometimes spreading between entirely separate populations, researchers have described whale song as one of the clearest known examples of vocal culture existing outside of humans, a slow, shared, evolving tradition carried entirely by sound. Sound plays a role in whale life that extends well beyond simple communication between individuals, touching nearly every part of their daily existence. From locating prey and navigating vast stretches of open ocean to maintaining contact with mothers, calves, and broader social groups, sound serves as an essential, constant thread running through nearly every meaningful aspect of a whale's life, in an environment where vision alone is often severely limited. Whales rely so heavily on sound partly because underwater visibility is often extremely limited, even in relatively clear ocean water. Compared to the open, largely unobstructed visibility available to many land animals, underwater visibility drops off relatively quickly with distance and depth, making sound, which travels efficiently and over great distances through water, a far more reliable and practical primary sense for many marine mammals to rely upon. Some researchers speculate that whale song may carry subtle information about a singing whale's size, health, or individual identity, beyond its more obvious structural pattern. Much like variations in a human voice can convey information about a speaker beyond simply the words themselves, some scientists suspect that specific qualities within an individual whale song, though not yet fully understood, may carry additional layered information relevant to listening whales nearby. Whale song continues even as scientific understanding of its full purpose and meaning remains genuinely incomplete. Despite everything learned so far through decades of dedicated recording, observation, and careful analysis, much of the true underlying meaning and full communicative depth of whale song remains, even today, an open, actively studied mystery, quietly continuing far beneath the surface regardless of how much humans have yet managed to fully understand. Right whales, named for once being considered the right whale to hunt due to their slow speed and high oil yield, produce their own distinct set of low-frequency calls, separate from humpback song. Rather than singing structured, repeating songs, right whales typically use simpler, shorter calls to maintain contact with one another, particularly useful given their tendency to spend considerable time near the ocean surface in relatively open water. Grey whales produce a range of grunts, moans, and pulsing calls, distinct in character from the melodic songs associated with humpbacks. Because grey whales follow a different migratory and feeding pattern compared to humpbacks, spending considerable time near coastal areas and shallow feeding grounds, their vocal repertoire has developed along its own separate path, suited to the particular acoustic and social demands of their specific lifestyle. Beluga whales are sometimes nicknamed sea canaries because of the unusually wide range of chirps, whistles, and clicks they produce. Known for one of the most varied vocal repertoires among all whale species, belugas produce sounds audible even through the hull of a boat, a striking contrast to the deep, often barely perceptible low-frequency calls produced by some of the larger baleen whale species. Narwhals, sometimes called the unicorns of the sea due to their long, spiral tusk, also rely heavily on clicks and calls to navigate and communicate within the cold Arctic waters they inhabit. Living in an environment where sea ice can limit surface access considerably, narwhals depend heavily on sound for orientation and social contact, much like other toothed whale species adapted to similarly challenging underwater environments. Whale calves begin hearing sounds, including their mother's calls, even before birth. Because sound travels effectively through water and tissue alike, a developing whale calf is likely exposed to certain low-frequency sounds from its surrounding environment even while still inside its mother, potentially beginning its lifelong relationship with underwater sound before it has even taken its first breath. Some researchers have observed possible call and response patterns between certain whale species, suggesting a degree of interactive vocal communication. Beyond simply producing sound independently, some studies have documented instances where one whale appears to vocally respond to another in a manner suggesting a loosely interactive exchange, rather than each individual simply calling out separately without any responsive back-and-forth pattern. Underwater sound can be affected significantly by water temperature, salinity, and depth, all of which influence exactly how far and how clearly a whale's call ultimately travels. Because these physical properties vary considerably across different ocean regions and seasons, the same whale call might travel dramatically different distances depending on the specific underwater conditions present at that particular time and location. Whales are believed to sometimes adjust the specific frequency or loudness of their calls depending on current background noise conditions. Similar to how a person might naturally raise their voice in a noisy room, some evidence suggests whales may adjust certain vocal characteristics in response to increased ambient ocean noise, an adaptive behavior that nonetheless has practical limits when background noise becomes especially persistent or severe. Whale song recordings have been used in various therapeutic and relaxation contexts by humans, largely due to their slow, low, soothing qualities. Beyond their scientific significance, recordings of whale song have found their way into meditation, relaxation, and sleep-focused audio content, valued by many listeners for the same slow, patient, low-frequency qualities that originally evolved for entirely different underwater purposes. Researchers studying whale song sometimes travel to extremely remote ocean regions specifically to record underwater vocalizations in relatively undisturbed conditions. Because background noise from shipping and other human activity is less pronounced in certain remote ocean areas, researchers occasionally focus recording efforts specifically in these quieter regions, hoping to capture whale vocalizations under conditions closer to what might have been typical before large-scale industrial shipping became common. Whale populations in different ocean basins, such as the Pacific, Atlantic, and Indian Oceans, generally do not intermix enough for their respective songs to directly influence one another very often. Because whale migration routes are generally confined within specific ocean basins rather than crossing freely between them, songs tend to evolve somewhat independently within each major population grouping, contributing to the noticeable regional differences researchers have documented among various humpback whale populations around the world. Some whale researchers spend entire careers dedicated specifically to studying and cataloging the gradual, ongoing evolution of a single regional whale song over time. Given how slowly and subtly whale songs typically change from year to year, tracking their gradual evolution in meaningful detail often requires many years, or even decades, of consistent, dedicated long-term research, making this a genuinely patient, long-term area of ongoing scientific study. Whale song has occasionally been performed alongside live musicians in concert settings, blending recorded whale vocalizations with human musical instruments. A small number of composers and musicians have experimented with incorporating actual whale song recordings directly into original musical compositions, drawing creative inspiration from the deep, resonant, patient qualities that make whale song so distinctive among all animal sounds. Whale song frequencies can sometimes be felt physically, rather than only heard, particularly among the lowest and most powerful calls. Because extremely low-frequency sound waves can sometimes be perceived through vibration rather than traditional hearing alone, particularly powerful whale calls occasionally produce a sensation some divers and researchers describe as feeling the sound moving through their body, rather than simply hearing it in the conventional sense. Whale song research often depends on long-term funding and sustained institutional support, given how many years of consistent data collection are typically required. Because meaningful patterns in whale song evolution and behavior often only become clear across many years of accumulated recordings, this particular area of marine research depends heavily on stable, long-term support, a quiet reminder of just how patient and sustained genuine scientific understanding of these slow, evolving songs must ultimately be. Whale song appears to include occasional new, experimental sound elements introduced by individual whales, some of which are adopted more widely and others of which quietly disappear. Much like small variations that occasionally arise and either spread or fade within any evolving tradition, individual whales appear to occasionally introduce small new vocal elements into the shared song, some of which are picked up more broadly by the population, while others simply vanish without lasting influence. Whale calves typically remain close to their mothers for roughly a year, during which time considerable vocal interaction and bonding takes place. Throughout this extended early period, calves rely closely on their mothers for guidance, protection, and likely early vocal learning as well, gradually gaining the experience and vocal development needed before eventually becoming more independent later in life. Whale song does not appear to require any specialized external structure or object, relying entirely on internal biological mechanisms within the whale's own body. Unlike some animals that use physical objects or environmental features to help produce or amplify sound, whales generate their long, complex songs entirely through internal biological structures, without needing any external tool or resource beyond their own bodies. The exact anatomical mechanism baleen whales use to produce sound without exhaling air through the blowhole remains an area of ongoing scientific study. Researchers have proposed that sound is generated through the movement of air between internal structures within the whale's respiratory system, allowing continuous vocalization without a continuous loss of air, though the fully detailed mechanics involved continue to be refined through ongoing anatomical and acoustic research. Whale populations recovering from historical whaling losses are being closely monitored partly through continued analysis of their vocal activity and song patterns. Beyond simply counting individual whales through visual surveys, researchers use ongoing vocal monitoring as an additional valuable tool for tracking population recovery, distribution, and general health across various whale populations still gradually rebuilding their numbers after considerable historical decline. Some marine protected areas have been specifically designed with underwater noise levels in mind, aiming to preserve quieter conditions supportive of natural whale communication. In addition to protecting physical habitat and prey availability, certain marine conservation efforts now specifically consider underwater acoustic conditions, recognizing that a genuinely protected habitat for whales must also account for their fundamental reliance on a relatively undisturbed underwater soundscape. Whale song has occasionally been detected traveling across entire ocean basins under especially favorable deep-water acoustic conditions. While not a routine occurrence, particularly powerful and low-frequency whale calls have, under specific and relatively rare conditions, been recorded reaching remarkable distances, offering a striking demonstration of just how far sound can genuinely travel through the right stretch of deep, open ocean water. Researchers continue to develop increasingly sophisticated underwater listening networks specifically to improve long-term monitoring of whale populations and their vocal behavior. As underwater recording technology continues to advance, scientists are gaining access to increasingly detailed, continuous, and widespread data regarding whale vocalizations, gradually deepening our collective understanding of a behavior that, despite decades of dedicated study, still holds a great deal of genuine, unresolved mystery. As our journey through the songs of whales comes to a close, perhaps the ocean feels a little different now. Not simply a vast, silent expanse of water, but a space filled with long, patient music, drifting for miles through the dark, changing gradually year after year, carried by creatures who may never fully explain to us exactly why they sing at all. We've drifted past songs built from repeating phrases, past mothers whispering quietly to their calves, past an entire ocean population slowly, collectively revising the very same tune together, season after season. Somewhere beneath the surface tonight, a whale may be singing exactly the same song it sang last year, or perhaps something subtly new, carried outward through the dark water toward another whale, listening quietly, somewhere far away. Now you can let all of that drift softly into the background. Let your breathing slow. Let your shoulders loosen. Let the images fade from bright detail into something softer and more distant, like a low, patient note fading gently into deep, dark water. And if you enjoyed this journey, perhaps you might like, subscribe, or share a thought below. It helps other curious minds find their way here, too, one quiet current at a time. And if you happen to still be awake, there will be another slow journey waiting for you on the screen, another gentle corner of the ocean to drift into quietly. But for now, let your mind grow still, and let the day fall away. Sleep well, and good night.